Evening, everybody. Apparently there's some difficulties getting into central Cape Town this evening with traffic and stuff, so I think there's more people on their way. But for those that you made it, well done. You clearly know the shortcuts. We've got an interesting session tonight with Devet that's going to be presenting to us. Just by way of show of hands, who here is a Snowflake user? So who here is actively using Snowflake? Okay, cool. 4 or 5. How many people know what Snowflake is? Okay, wicked. How many have come to the user group before? Okay, so all of those that have come for the first time, welcome. It's a safe space. We're a friendly bunch. Feel free to talk to the person behind you, to the left of you, in front of you. They're all very nice people. Cool. Without further ado, I'm going to kick things off. So if this is your first time coming to the user group, why does the user group exist? So we go through these slides every time. So once you come to the second or third one, you're typically probably switched off at this point. But it really is for people to get like some insight into how Snowflake works. So talking about things like best practices, like I said, talk to the person next to you, behind you, in front of you, to the side of you, is to grow your professional network. There's really interesting people in the room doing interesting things in different industries and different sectors here in Cape Town. So it doesn't necessarily have to be a Snowflake conversation. It could be something a lot more interesting. And then to stay current with Snowflake, like Snowflake are releasing new capabilities all the time. We have the privilege of being like exposed to this stuff. And so it's the ability for us to share that with a broader audience. I'll start off by telling everyone we love QR codes. So if you've got a phone, get it out. There's plenty of QR codes to snap, lots of interesting resources. So who am I? So my name's Douglas. I'm a director of a company called datalab. We're actually a Snowflake partner, but we started the Snowflake community about 2 years ago, myself and Reza, because we've been building communities in Cape Town for many years before this on various different technologies and different partnerships. And we thought it would be appropriate to build one around Snowflake. Community doesn't exist unless people actually participate. So if you've got case studies, you've got interesting stories, we've heard from really great people, like we had Alan Gray here last week. Before that, we've had guys from Wonga, Pages Now. I'm trying to think of everybody off the top of my head. Makuru, Games Global. So a long list of Snowflake customers here in South Africa that are willing to come and share their use cases, how they build it, what the strategy was behind their use case, some of the pitfalls that they've come across, and their kind of learning experiences. So unless people come and share, there's not much to talk about. We want to hear about those innovative use cases, the best practices, and it doesn't have to be about a use case that went well. We've had people actually, being quite open about where they've done things wrong or differently and where they've found solutions for those problems. By the virtue that you're in the room, you've probably already joined the chapter. If not, Bronwyn joined you up as you try to walk through the door. But if you haven't joined, please join. The reason for joining is that we can spam you with email. So basically, every time that we put a new user group event up, you'll get a nice email just telling you that the user group event is on. You can sign up. You can attend. You'll find us in the bottom left-hand corner of the Europe and Middle East part of the user group webpage. We share these slides with people. So we've got we wanted to try and give ourselves some kind of ambitious targets as a community. And so it's not about the numbers, but it's about the intent. It's about creating content that counts, that encourages people to attend. It's about creating a community where people get value. And so these metrics are just a kind of a representation of that. In themselves, they're not the target. The target is to create a community of people that want to share their experiences. So we set ourselves some targets to reach 1,000 members by the end of this year, to have 100 attendees at one of our events, to be in 2 locations, both here in Cape Town and Joburg, to run 10 events from February through to November, and to have 2 after parties. So how well are we doing? So we have, as of this morning, 573 members. We have, on average, 87 people attend this year the events. That's both in person and online. We've only had events in Cape Town, and we are having one in Johannesburg very soon. This will be our 4th event, and I'm going to put it in orange because we are going to have a party soon. I'll tell you about that just now. This is what our attendance typically looks like. So last month we had just upwards of or around 90 people. We had about 15 people online, and the rest of you were in person. The traffic was obviously much better that day. How are we tracking against our target? So you can see that I'm a data person. I love a metric and a KPI, and I love a graph. So we're just dipping below our line now. So we're going to have to do something to correct that. And I'll talk to you about how we're going to correct that very soon. If you want to stay up to date, you can also join our LinkedIn group where we try and like post content on there, not as regularly maybe as we should. All these events are actually broadcast. So we have obviously an attendance online. So they get recorded and then we share them on a YouTube channel. So far, we've got all of our recordings from this year and a couple from last year as well. So that's what the user group is about. It's about trying to build a community. So announcements and upcoming events. This is where it gets a bit more exciting. So here we're in May, we're here in Kloof Street. We're going to have a really interesting talk from Devet about what makes Snowflake different. So for all of you that are relatively new to Snowflake, we've had feedback from the user group saying, cool, it'd be nice to have something which was a bit more, let's call it entry level, like what is Snowflake, what makes it different? So Devet's going to take us through some interesting kind of differentiators of what makes Snowflake an innovative AI cloud data platform. Next month, we're going to be at Innovation City, which is just around the corner here. They've got this brilliant auditorium space downstairs. We're just trying to secure that for the 24th of June, and that's where we're going to have our birthday party. So if you were here this time last year, we had a wicked birthday party. We had our own snowflake cake. It's going to be our second birthday party. As I mentioned, it's going to be in Innovation City. The theme is going to be about community and collaboration. So we're going to have hopefully some really interesting speakers come and talk to us about how to do things like data sharing, the value of data sharing, collaboration, and using Snowflake as a platform to support that. We're going to have some great prizes. So far, we've secured 2 SnowPro Core exams, so they're a couple $100 each. So if you want to do that, then enter the competitions, the Slidos that we have at the end. And we're going to have some community awards for people that have attended, you know, and have basically contributed to the community. Bring a friend, yeah? Like we've got a massive space to fill. Bring a friend. There'll be lots of booze. There'll be lots of food. There'll be lots of great content. So hopefully you'll come and attend. For those of you that are jet setters, the Snowflake Summit, this is their biggest event of the year. It's in San Francisco. If you are going or if you intend to go, it's in a week's time. Book your flights. They might be quite expensive. Scan the QR code and you can get some money off of a ticket. In terms of some other up and coming things, so there's some really interesting innovations around SAP and Snowflake. They've recently built like this low friction connector that allows you to basically integrate SAP data directly in Snowflake in real time. Interesting talk on the 28th of May, so towards the end of the month. From prompt to production, so how to build a real-time fraud detection model. This is on the 17th of June. So these are all webinars that you're welcome to go and attend online. We do this every month. I won't spend too much time on it, but literally, and these are the things that I find interesting. I'm a big fan of all the AI stuff. If you've been to any of our previous events, I talk no end about all the AI SQL stuff. But there's been a whole load of releases since last we met. So you can basically, through this thing called AI function user control, who has access to these cool Snowflake AI SQL functions. This one called AI Complete, basically they've enabled some additional functionality on there where you can read data from PDF documents. There's been some interesting things around Apache Iceberg and being able to access data that's on Databricks on Azure, so creating interoperability between different platforms. Your ability to create your own fine-tuning models in Snowflake, so your ability to take their Arctic extract model and actually fine-tune that for yourself. That's cool. And then loads of other innovations around AI parse document, which is another feature that allows you to take PDFs and basically extract information from them, images, text, and basically pass them out into content that you can then go and analyze later on. Another feature they released with this AI Complete function was the ability for you to basically analyze video. So you can upload a video and then you can go and extract information about what brands are in there, what were people saying, how many people were in the actual, basically prompt engineer your way to extracting some data from video content. The SAP connector that I mentioned, that was released on the 4th of May. And then some similar functionality in this AI classifier allows you to talk to documents and basically classify them. So you could say, is this a legal document or is this a invoice? And then from there, you could push documents downstream to other different processes. So some really interesting things. All of this stuff is on Snowflake's like release website. So if you're interested in any of these things or you want to chat to someone about any of the stuff I briefly mentioned, then you can like tackle any one of the user group kind of helpers. And that's it from me. So I'm going to hand over to Devet. I'm very lucky I get to work with Devet pretty much every single day. So he's going to take us through some really interesting stuff around Snowflake. Hopefully it's really useful to those of you who don't know too much about Snowflake. Maybe for those of you that think you know a lot about Snowflake, maybe there's some interesting insights in there as well. So I'm going to hand over to Devet for the rest of the evening. Cool. Back to you.
All right, cheers. Thanks, Douglas. Can everyone hear me all right? Everyone at the back? Okay, cool. Yeah, so just a quick overview of today's session. So I'm going to do a quick introduction, 5 minutes, then spend the bulk of the time giving you guys an overview of Snowflake, the sort of core foundational aspects of the platform. And then I'll quickly discuss some of the integrations with common use case partners like Microsoft, for example, then jump into a demo, and then there'll be some time for Q&A and then a little pop quiz right at the end. So take your notes, and there will be some cool prizes thanks to Snowflake. So about me, my name is Devet. I'm a data engineer with datalab, been with the company for about 8 years. I am a husband, a dog dad, a tech nerd, avid gardener, and braai enthusiast. I used to be a gamer, but these days my gaming PC only runs Olama, so that's kind of fallen by the wayside, unfortunately. You can scan my QR code to my LinkedIn page there if you want. I do also post some blog articles on Medium every so often. So I work for a company called datalab. We are a Snowflake data and analytics consultancy, and we work with organizations to help them realize value from the Snowflake platform, as well as the broader ecosystem of partners that sit around it. So just some of the logos on the screen here, like Matillion for the ETL process, ThoughtSpot for some disposable analytics, Sigma for a bit more structured feedback, and then we used to run the Power BI user group back in the day, so we're still big fans of Power BI. Douglas over here is a Power BI wizard and a DAX ninja. So I think like jumping into Snowflake, I think this is something that the next slide, let me just see where's my next slide. Sorry. No, it's not. Maybe the clicker will work. There we go. This is something that Snowflake's been punting for a very long time. AI is everywhere these days, and I think this is something that's very salient, is that there's no AI strategy without a data strategy. It's foundation to building good stuff. And what Snowflake means by this is that like this is sort of the journey that they want you to undertake, is that moving from data to AI, but AI isn't the purpose of it in itself. The purpose is to actually transform your business. So it's all good and well getting Gen AI and, you know, having it build cool code and generate awesome pictures or whatever, but it's about how you're actually transforming your organization using these tools. So speaking to that, I think like this is a kind of architecture diagram that everyone that's in a sort of data analytics or data engineering space is quite familiar with. On the left-hand side, you've got pretty well-defined sources, and you've got some kind of ETL process that moves it through this medallion architecture, and then you've got consumption layer at the end. You know, whether it's not it's your paginated reports, it's applications, you're sharing it, or you're doing your data science workloads. However, what has happened is that these technologies obviously don't sit still. Like this would have been very, very salient, I don't know, maybe 10 years ago. Subsequently, you know, things like open table formats have come along. You know, you want catalogs to actually store this data, and preferably you want these to be open standards. So something like Apache Iceberg. And then, of course, in this consumption layer to your right or to my left here is that there are different engines for different use cases. So, you know, something like on your BI layer, you know, it might be straight SQL. Your data science people want to use something like Python in the application layer. You might want to build a Streamlit app, and while sharing, I mean, there's tons of ways to share data. So that was like the first disruption that sort of came, is that all of these open table formats existed. The next disruption is that, you know, with the advent of AI, is that all of a sudden 80% of the world's data has become available. It's mostly in an unstructured format. It's PDFs, it's images, it's video, it's audio. And there's tons of AI integrations all over the place for actually consuming this data. And so what this leads me into is that we don't know what the landscape is going to look in the future. We want to prepare for it. So, back in the day in the on-prem world, here on the left of the slide, you'd have your basic sort of ETL process. You might be connecting to some kind of OLTP system. And then as you're moving into the machine learning layer, you've got, maybe some like cybersecurity logs or IoT things. That's pulling through there. And, in the AI world, we've got the data mesh and unstructured data, LLMs. We don't know what it's going to look like in the future. The only thing that we do know is that the volume of data is going to be increasing exponentially. So what this means is that you need an architecture that you can actually connect all of these various little silos of information. And it needs to be governed across the board. So, whether or not you've got some container application sitting somewhere, you've got structured data, you've got semi-structured data that's coming from an API, you've got call center recordings that you're ingesting, and then even some data that might be sitting in some kind of open table format like an Apache Iceberg. And at the same time, you want to have your various different data warehouses that are sitting here in this square to the left that might contain specific regional restrictions of where the data can be deployed, depending on the environment that you are. And, that's kind of where Snowflake fits in, though, with the Snowflake AI Data Cloud. It started off as a data platform, but then subsequently, like Douglas was saying, the guys at Snowflake, they're constantly evolving. There's new releases weekly, like the stuff that you can do with Snowflake is just getting more and more awesome, especially for me as a developer. It's a joy to use. So at the core of Snowflake, the sort of foundational aspect is this concept of interoperable storage. So the capability that you have is that you can query unstructured, semi-structured, and structured data, and that it is stored in a very, very efficient manner. It's something called micro-partitions that are columnar and they're compressed, and they can be deployed on any cloud. So your Snowflake instance, so any of the big cloud providers, so AWS, GCP, and Azure. And then around this layer sits your elastic compute. So basically what this means is with a single line of SQL, you can scale up your compute. So you can go from, 8 core, 16 threads, X amount of memory, and it's literally a one-liner, and you can scale that compute up and you can scale it back down again. You can also scale it out. And then also within this elastic compute layer, you can interact with your data in multiple different programming languages as well. So us as data analytics consultancy, it's mainly going to be SQL and Python. If that's not your flavor, you can also do Java and Scala. Around this layer, then, is the Cortex AI that's been developed by Snowflake that basically enables you to interact with large language models within your Snowflake instance. So it's not like your data leaves your Snowflake account. It sits within there, and you can actually leverage other models that, depending on what the availability on your region. But then you can also enable it to actually leverage models that are outside of your region, once again with a single line of SQL. Yes?
So, say and it can engage with other AIs. Is this engagement with centralized and decentralized models? When I mean decentralized, I mean Olama. Decentralized or cloud?
No, so these LLMs are deployed on your Snowflake tenant, so on your Snowflake account. So you don't need an Olama, for example, to now run it on a local GPU. So you can integrate with an API to Snowflake, yeah, and you can do MCP, all of that good stuff. So you can hook into your Snowflake, so you can have your Snowflake data there secure, governed inside of your environment with the models, and then you can hook into that with an MCP server. Yes, CLI as well. You can do CLI, and recently Snowflake actually released their so Cortex Code is has a CLI component now as well, where it's basically through the terminal directly on your Snowflake account, and you can interact with your data. You can have it write queries against it. You can build it SQL. Yes, absolutely. You can build the SQL files, upload all of that good stuff. So that's kind of the Cortex AI, and then sort of the brain of the system is this cloud services layer. And here basically Snowflake takes care of a lot of the dials that you have in your traditional your traditional sort of database deployments, if you think back on like your Microsoft SQL servers and those kinds of things, where a lot of the pain points typically around like managing indexes and like updating statistics and having like all of those kind of performance tuning type jobs, you can still do them, and Snowflake still offers you a lot of the dials. But the main point is that your governance and all of that stuff is built in. So as soon as that
stage 6 load shedding. Does Snowflake work in stage 6 load shedding?
But you can connect, yes.
You hear that if you can connect. My reality is that I build sovereign architecture, which means it's architecture that serves. It serves Mitchell's Plain. It serves Dunedin. It serves Kailicha because those places don't have connections, right? So how does Snowflake operate in those type of neighborhoods? Because I do believe that AI is the way to rebuild the infrastructure in those places. But how do we go about it? If Snowflake has all of this to offer, how does Snowflake operate in load shedding stage 6, where it's 6 hours out and we need to operate?
So from a data center, I can answer part of your question.
Okay.
So from a data center perspective, Snowflake has data centers across the world, yeah, in various, and on those different providers, so AWS, Azure, GCP. They have this concept, what they call snow grid. So behind the scenes, they've got their own pipes connecting these different things together. So I don't know if you can remember a couple of years ago, we had a cable that got cut between us and Europe, and everybody's Snowflake didn't go down. Snowflake rerouted themselves.
Cable. They don't like, yeah.
And because they replicate your data, if you choose to various different data centers behind the scenes automatically, you don't have to go and do any kind of backup restore replication. You can just switch it on. Your data exists in 2 or 3 different locations already. And so you can have that level of uptime. Now, obviously, if your pylon goes down, they're not going to be able to connect you to your data center. But assuming that the first mile problem is solved for, they manage the rest of it. Yeah. Having said that, there's a data center right down here in AWS Cape Town. And there'll soon be other ones up in Johannesburg as well.
Probably when Microsoft finishes, might join them because they are busy right now.
Yeah.
But see, it's amazing, right? But we're still not solving the problem. The problem is that in South Africa, we have constrained resources. Silicon Valley works on the priority that resources are always there. Electricity doesn't work. People that actually don't know load shedding. They've never sat with a candle in a family for 6 hours, and all you have is a to a community. If that's the logic, I then change my shift of mentality and I'm like, then let's build an AI that can survive in that 6 hours. It needs to become offline.
Yes.
So the same functionality that's happening for when we are plugged to Wi-Fi and data, I do believe that we need to give that to places like Danone, Kailich, and then. But not just that, we also need to give it in 11 linguistic languages. Because I do believe that English is segregating, because English has high linguistic language, and then it has advanced language, and then it has weak linguistics. I'm telling you now, Kailich and Danone, they don't know. And yeah.
So I think I'll take a point offline.
Yes.
We'll have a talk about AI.
Yeah, I'm passionate about it. So I like what you guys are meant to get out there.
Yeah, sure. Yeah,
So I really see all of this, and today I get this here. So thank you.
So yeah, it's a very similar presentation to the last one. Cool. Yeah, so just being cognizant of time, I'm just quickly going to go through all of these like workloads that Snowflake enables. So another fantastic implementation that Snowflake brought in is Snowpark. So basically like container services, but you now don't have another deployment that you go and need to manage. It's all from within your Snowflake account. It will run on whatever flavor of like the cloud provider is that you choose. Snowflake manages the resources for you. Another fantastic tool for development, and we're going to get into this a little bit later, is zero copy cloning. So this is to like really speed up your development lifecycle. You can basically clone any object, so database, a schema, and a table, for example, and you can create a clone at that point in time, do your work, and the clone actually doesn't consume any storage until you start making changes to that data. And then similarly, right at the end is like the distribution aspect of Snowflake. So you can share your data with the secure data sharing or reader accounts that you can set up for people. And once again, that data doesn't physically move anywhere. They're querying it directly out of your account and with your role-based access control. So depending on how it's configured, it will be restricted. So it can either be then at a row level where it's like row level security, or it can be at an object level, so specific columns, or it can even do stuff like data masking, and you can set up data clean rooms to securely share only what you need to share. And that brings me back again to like the sort of foundational pillars of Snowflake, that it needs to be easy, trusted, and connected. And it needs to be something that's easy to manage, easy to adapt to, and also easy for your developers to adopt. You should be able to, move and like leverage data with as little friction as possible, and it needs to be able to communicate in different formats with each other all around the world. So not just restricted to your region. You should be able to, if you've got a large organization and this is something that Snowflake can do, is that you've got different business units in different countries that have their own separate Snowflake accounts, but they need to share information with each other. Gone are the days of setting up something like an S3 bucket is you don't even need to do that, or an FTP or an SFTP. Basically, you set up your shares, you configure the access, and the data it's instantly available. There's no delay, there's no lead time in development. It's basically get your governance right, the data will be there. So quickly moving through how Snowflake helps your various different workloads. Of course, from a data engineering perspective, it really simplifies building out your ETL workloads. And there are some fantastic tools in the broader community of Snowflake partners that you can leverage there. So one example being something like Matillion or Fivetran that really solves the E part for you quite easy. And then in the last 6 months or so, Snowflake has also, no, that's actually a bit more than 6 months. In the last year, Snowflake's also launched their own ETL tooling called Snowflake OpenFlow, and that is built on, once again, it's got open source foundations. It's built on Apache NiFi. You can run that either in your own compute environment, like on AWS or Azure, or you can deploy it within Snowpark container services. And then from there, you have complete flexibility using a tool like OpenFlow based on NiFi. You can build any kind of pipeline that you can think of that is available, and it's got a large open source community, and it's it's a really cool tool to use. From a analytics engineering or data analyst perspective, I think the example there talks about like consolidating investment data sets. So, but once again, because you can access data in a multitude of different formats, you can quickly come up with answers. You know, if someone has a burning question for a specific report, but it's only an output that's coming from some kind of JSON file somewhere, you can turn that JSON file into rows and columns, combine that with a CSV that sits somewhere, and it's once again, there's nothing fancy or like, you know, complicated transformation techniques that you need to do. It's all standard ANSI SQL that you can interact with this data, even things like JSON or XML or Parquet or Avro. Then from an AI perspective, once again, with all of those Cortex AI features that Douglas spoke about earlier, you can call all of these fantastic functions with simple SQL. Cortex AI is like, here's my function that I'm calling, these are the columns, so this is the payload that I want to pass to this AI function. I want to transcribe call center recordings, or I want to process some kind of information out of an image. It's all a single line of code, and you're off to the running, and then up and running, sorry. Then on top of that, now features that Snowflake has added is things like Snowflake Intelligence, where you can set up your semantic views and your analyst, and you can actually have that chat interaction with your own data. And then subsequently, after that came live, there's also been Cortex Code's been live now as well, that can actually interact and help you code with your own data, governed with your own role-based access control permission. So it can profile and analyze your data for you as you're coding along. This does come with a caveat that it is not free to do that. So you need to have proper guardrails in place. Once again, it comes back down to the governance being foundational to that. Like once your governance layer is sorted out and you know exactly who needs to be able to see and do what, where and when on what warehouses, then the rest of it all kind of flows through, and you have this incredibly seamless experience. And also with these AI features is you can once again interact with the data in the language of your choice. So you can set up a Python notebook right inside your Snowflake account. They've got most of the major libraries that all of the Python enthusiasts use. So then you can do your complex data science-y kind of workloads. That's not really my purview. I'm not a math person. Then I think the other thing that really sets Snowflake apart is this concept of the Snowflake marketplace, where you can share data with other providers or internally inside an organization. The data stays secure, it stays in the proprietary environment where it belongs, and you can interact with that data. So there's opportunities to monetize your data as well with these secure shares, and there's a ton of vendors out there that are already sharing your data. So if you have some kind of integration with one of the labels that they currently have on there, you don't even need to build an ETL. Your data doesn't need to move. You can literally skip the entire sort of process of your data mesh or data warehouse or data marts, whatever you're constructing. Then I think like this is something that's fantastic on Snowflake as well, is this whole concept of limitless compute. You can dynamically scale up and scale down your warehouses. You can scale them out as well. You have no issues around resource contention. So if for things like workload isolation and concurrency, once again, like this, sorry, I'm going from the bottom up. The concept of separation of storage and compute. So typically the storage aspect of your account is the cheapest aspect. I think at the moment it's something like about $24 per terabyte of storage. So that's literally nothing to store data. And the compute aspect, you've got full control over. And it once again, coming back to the easy, trusted, and connected, it's straightforward to interface with it. It's a single line of SQL, and you've doubled your CPU, you've doubled your memory, you've doubled your SSD. And once again, it's a one-liner to change it back to extra small again as well. And also the things are scaled in t-shirt size. It's easy to understand. Each t-shirt size, everything doubles. Just to add to that, though, also the rate at which it consumes credits double. So then there's so just a caveat to be aware of is that you can go to a 6XL, we're going to have 512 cores, but then you're also going to be burning 512 credits an hour. For CDC, so Snowflake has some fantastic built-in functionality called streams that you can set up that basically tracks changes on an object. It doesn't have to be a table. So that's the kind of traditional use case for CDC that I feel like most people are familiar with. You can also do it on things called a stage in Snowflake, which is you can almost think about it as like an S3 bucket or a folder. You can have different kinds of stages. You can have internal and external stages. So your data doesn't have to live inside of Snowflake. You can also have it on S3, on AWS, and it's all secured through the sort of standard frameworks for authenticating to AWS, like with IAM, or through like your Azure. I've forgotten the terminology now. The Azure, anyway, the Azure version of that. So it's very useful for efficient incremental loads on data. So as files come in, you can literally stream them into your tables, and it'll track the changes. And you can then also further automate that with stuff like tasks, or once again, then you can consume these streams from something like OpenFlow, or you can consume them with a straightforward SQL script, Python notebook, you name it. Another cool thing that Snowflake has also launched, and this is more around like once your data is being transformed, is dynamic tables. So basically you give the table a definition, say this is the query, this is like all of the various dimensions that this fact table is looking into, and you go and deploy this thing as a dynamic table. And then as the source data in this sort of DAG changes, your destination outputs will change, and you can give these objects a lag. So you can either schedule them and say, okay, cool, I want this to refresh every 5 minutes or every hour or every day. Or you can say, well, actually, I want to be able to refresh this table ad hoc as new data comes in. So then once again, you set that scheduler to be disabled, so it's not scheduled. So it'll track and keep history of like what's going on, what changes are coming through. But until you tell the table to go and refresh, it won't refresh. And then that's basically all of your transformation logic stored in the table definition. It's very cool. Then another feature, and this is great for developers out there. This concept is zero copy cloning. So this once again for spinning up labs. You don't have to go and restore a backup or ask for someone to restore a backup, spin you up a lab, provision a server that you can work on. It's a one line of SQL. It's like, okay, cool. The development team needs that prod database cloned. And then with that cloning, all of your role-based access control stuff still applies. So you can clone the production environment, but have full confidence that if your dev team has very restricted access and that certain columns are personally identifiers, so they need to be redacted or not visible at all, but certain aggregate columns still need to be visible so that they can do their unit tests, then like your role-based access control hierarchy takes care of that. Like the sort of sensitive data won't get exposed when you spin that up to a lab unless you have the required privileges to actually see those objects. So from a data ops and from a DevOps perspective, this is fantastic. Also, like it says on the slide, point in time snapshots, or if you want to do some kind of what if analysis. And then the other neat thing about these zero copy clones is in the name, they don't actually copy any data. So basically the underlying architecture is based on something called micro-partitions that I spoke of earlier. And these micro-partitions are immutable. So when you're calling this zero copy clone command, what you're actually only cloning is the metadata around that data. And then it basically has pointers to the micro-partitions that support this, that sit in the prod environment. And until you start making changes to that clone that you've made, it doesn't actually consume any additional storage. And then the subsequent storage that you're consuming for that is only for the records that you've actually changed. So very cool feature. Secure data sharing. I've spent a little bit speaking around this as well, but once again, these are the kind of components that you can share. So you can share tables, external tables, secured views. So the difference between a secure view and a regular view, secure view, basically you cannot see the view definition. So I can't see what actually goes into transforming the data, but I can give the data, I can have access to the data. With UDFs, it's like calling an API. Secure materialized views is basically where you want to pre-materialize certain objects in a view, so that it doesn't actually go and run and execute that query and churn along and does all the joins that you might have in your view or certain case statements or whatever. It will pre-aggregate and pre-compute the data so that it's like instantly available. And then, yeah, this kind of all sort of falls under these kind of data services. So you can do stuff like your data clean room. And I think like that sort of slide describes it nicely, but the data doesn't actually move between the two systems. You're not building pipelines and transferring data, sending stuff around. It's instantaneous and available. Then alongside the secure data sharing is this concept of the Snowflake marketplace. So there's hundreds of providers on there, and it's basically, some of them are free that you can connect to, like right off the bat, and you can hook your Snowflake account into it. Some of them are paid. You can contact these organizations through the marketplace, and then instantly that data feed will be available to your account. And like, so just a quick, this is probably an old one already. There's hundreds more, like all of these kind of providers you can instantly connect. So, you know, some of them would be data providers like S&P Global, or SaaS service like a HubSpot integration, or even business applications like the announcement that Douglas made with SAP on SAP Business Data Cloud. You basically have zero ETL integration, SAP environment straight into Snowflake. Anyone that's built an ETL process ingesting data from SAP, like, it can be quite tricky, and this, you know, the tables are all 500 columns wide. Yes, sorry. Okay. So,
because a lot of these seem like established companies. I'm talking about, like, you know, the guys on GitHub, guys on Hugging Face, who are also building data providers and SaaS providers. How do we go about incorporating them into Snowflake if I'm using it?
So if you want them to share stuff on Snowflake, like, they would need to have a presence on the platform. Then they can securely share it, and you can become a provider and you can host stuff. The other alternatives, it would be to, you know, use your more sort of traditional ETL integrations to move that data onto Snowflake. But you know, like, I'll get to that, like, you know, with like stuff like GitHub, like if you have a repository, you can integrate Git repo straight into Snowflake. And by and large, like the majority, unless there's some, you know, non-standard obscure Python libraries, you can, like, pretty much all of the standard stuff that people are using, you've got straight access to. Yes, yeah, GitHub is on here. Yeah, so the previous presentation that I did was it had a bit of a Microsoft friendly audience. Now, we have no issues with Microsoft. We've been building stuff on SQL Server for ages. So this is just touched on some of the kind of integrations that you can have in a Microsoft first environment. So, you know, your Active Directory sits on Microsoft. You might have some Fabric capacity workspaces, or you might be using Azure Data Factory. So I think this is a very cool announcement that Snowflake actually announced late last year, is that they're going to be fully interoperable with OneLake using Apache Iceberg tables. So that means that you can have like the zero friction environment where part of your estate might need to be on OneLake for some specific reason, or there's a specific business unit, but then you've got another business unit that sits on Snowflake. So with this, like, integration between these two platforms using these open standards, like Iceberg tables, you can actually have this zero friction environment. Then, of course, Snowflake integrates well with Power BI. There's a connector for that. You can build your models, no problem. You can use VS Code to interact with Snowflake. You can have Snowflake as a source or as a sink in Azure Data Factory or Fabric Data Factory. You can connect you can integrate your Azure blob storage with Snowflake via something called an external stage. So basically, yeah. Yeah, so you are not restricted by IDE. So it's got most IDEs will be able to connect to Snowflake. At the end of the day, there should be a connector. So, like, I personally use VS Code a bunch. Snowflake also has its own IDE built in called Snowsight. You can interact, like I said earlier, you can interact with the CLI if you want to. You can use something like Cursor as well. That'll work fine. You can integrate your Snowflake account with your GitHub, so you can literally connect the repo to your worksheet in Snowflake. You can, yeah, from a GitHub workspace, you should be able to access Snowflake as well. You can also integrate your Snowflake stuff with Azure DevOps if you want to like run CI/CD pipelines there, or you can run them through GitHub. And then there's like when it gets to CI/CD, there's tons of other tools as well that you can integrate. All right, so that leads, yeah. Oh, yes, sorry. I'm sorry, there were two questions. Yes. Yep.
Metadata management tools for Snowflake.
Metadata management tools. Well, yes. Yes, you can. So like a good example would be like using something like Streamlit that you can host natively inside of your Snowflake account. Yes, oh yes, you can do query tagging as well inside of your objects. So you can tag your specific objects. Your Horizon catalog, you can do that through the Snowsite UI as well. For managing your metadata. There's a few ways that you can do it. Yes, sorry, we had one more question. Oh, okay, cool. All right, cool. Before we get into the fun stuff, let's quickly do a little bit of a live demo. Let me just quickly hop open in my screen share here. So I'm just going to take you guys quickly through kind of some of the just a second. Sorry. I've got a security policy on this. You see, like governance is built in. Just a second.
Any other questions?
Are there any data lineage, visual data lineage tools similar to like DBT?
Yeah.
Yes.
So DBT is inside of Snowflake now as kind of first class entity. But so you can, and then like with some of the later releases now or recent releases, you can see a whole DAG in terms of things like the stuff that
yeah. So on dynamic tables, you can see your full DAG, and you can also have task tags as well. So if you chain a whole bunch of tasks together, and each task goes off and performs like stored procedures or any kind of other sort of workload, then you can see your entire task DAG as well. So sorry about this. I have a security policy on my laptop and I'm on a different network.
You get when scaling your Snowflake consumption and what structural architectural change did you make to mitigate it?
Don't ChatGPT questions and then I'm joking. So
I believe in agentic
cool. So
workflow.
So the biggest thing with Snowflake consumption is to understand the architecture, and then once you understand how it works, then you'll know what levers you have to pull. So as the vet mentioned earlier on, the biggest mistake people make is let's just go and scale this thing up to try and solve a particular problem. And you don't necessarily have to scale things up. You could scale things out. It depends on what type of workload you have. So the biggest mistake people take is they take the traditional route of how they use consumption and just think bigger is better, where it not necessarily is. So as an example, if you've got lots of people querying small queries, you scale out. You take a small like t-shirt size and you scale it out because you want that kind of multiple threads. You've got a really big complicated query, then you scale it up. You're accessing one big set of data, one big workload, you scale it up. So understanding how compute works is key. And then likewise, understanding how LLMs work. So what's a context window? What are tokens? How much do they cost? What am I putting in there? It's not just what I'm putting in, it's what I'm getting back. Yeah. So I mean, like one simple example, we had a client that basically was putting stuff into an LLM and asking for a JSON response. And in that JSON response, they were using massive like labels for their JSON. All of that is credit consumption. So call it element A, B, C, and D, and then it's going to be much, much cheaper for you. So it's understanding all of the different parts of the technology before you then go, it's expensive. Or you need to know what the different dials are that you can turn. A lot of the dials have been taken away from you, but you still need to understand at some level, like, what are the cost drivers?
That's what I like when you were going through, is that you can see this. Snowflake was built by people who love data, because people who love data worry about the nitty-gritty thing, but the nitty-gritty things count.
That's it.
Because that's what gives you control, and it's not about being a control freak. Because really, what you guys see is I build ecosystems, and I love what you guys are building, because what I'm trying to build in my ecosystem is the balancing and the imbalance, because ecosystems become imbalanced. So how do we rebalance that? So like you said, it's not about upscaling, it's about understanding the rules of engagement of the ecosystem so that we can know where we actually need to hit and stop burning tokens. That's what I'm trying to do. Yeah.
Cool. Thanks. All right, so can I quickly take you through some of the like really cool and sort of unique features from Snowflake? Time travel, querying semi-structured data, and then some items around the elastic compute, data sharing, and doing streams and tasks. So in the interest of time, I'm going to try and be quite quick. So this is your kind of standard interface now. It's called a workspace within Snowflake. This is your canvas that you're going to be working on if you've got a Snowflake account and you've opened it up. What you guys can see here is that this workspace is actually connected to a Git repository. Here we can see that same Git repo is there, and you can actually see that there are some modified changes. So in terms of your dev workflow, you can create branches and pushing stuff directly from here. You're not strictly limited to using Snowsite. If you're a Visual Studio Code, fine. Same thing in here. Got my repo connected. I've got my Snowflake connected there. There's all my queries. Happy days. I can interact with the data. So what I'm going to do here is I'm going to use the schema called time travel demo. And I'm going to just create a simple table, employees. And we're going to create a couple of engineers and marketing and salespeople, and we're going to give them salaries. Fantastic. And, this is all standard SQL. Here you go. Here's table output. Nothing out of the ordinary. We've got people, their jobs, and how much they are earning. Now, let's say I go and do something really destructive. I'm in a bad mood, or I'm not paying attention, and I actually accidentally go and halve all of the engineers' salaries. So very sorry for them. They're now all earning exactly half of what they did. Now, what you can do with time travel inside of Snowflake is I can actually query that table in the state that it was. Let's just say, for argument's sake, 60 seconds ago, and we'll see. Time travel data is not available. Okay, now I might need to go back a little bit further. Oh no, because the table hasn't existed for 60 seconds yet. Sorry. Let's just give that a couple of seconds, because I just recreated it. Let's see. Yes, sure. Any questions? And there we go. So that's there. You can see there's the original values for that table. They're back to their original salaries. So what I can do now is I can say, well, I want to compare these two objects. So what the data looked like a minute ago versus what it's looking like now. Once again, I'm too quick. Here we go. There we go. So okay, so now it's past a minute. So this example is obviously I'm doing stuff in real time now. So the changes are coming through quite quickly. But if we go maybe 120 seconds now, should be able to, let's give it a second. We'll get back to this one. Because I just recreated the tables. I shouldn't have done that. Sorry. Let's just go on, and I'll get back to that one just now. So another thing that someone might do is accidentally drop the wrong table. Doing a little bit of maintenance, doing a little bit of cleanup, and okay, well, I want to get rid of employees. And what you can actually do is a single line command called undrop employees. And if I check the employees table, data is back again restored. Sorry about the engineers, their salaries are still halved. So this has got to do with the micro-partitions, that how the data is stored, because a micro-partition is immutable. So once it exists, it exists forever, until you can actually configure like your time travel, like how far back you want to track changes before it'll eventually age out. Like, so that eventually that micro-partition will, so the path that it will follow is it'll go into your time travel, and then from time travel, it'll still stay in fail-safe for another 7 days. So if someone does something really destructive, there's no time travel or like very short time travel on the table, then you can contact Snowflake for another 7 days that you actually have a chance to recover that data before it's then completely gone forever. You can go up to 90 days back in time travel, no problems. Once again, like it will consume more storage over time, but then at the same time, storage is relatively inexpensive. Like the expensive part these days is compute. It's not storage anymore. Let's just quickly go back to my time travel comparison. We'll do that one now. Let's move forward. Sorry. So the other thing that I wanted to show is I wanted to be able to clone tables. So here it's once again straightforward command. I'm creating a table called employee backups, and I'm just saying clone the table called employees. Run that, and there we go. We've created a clone, and I'm just going to update that table to show which one is cloned and which one isn't. And then if I compare these two, you'll see that it has the exact same data, and that table is cloned. Now, where this gets interesting is I can create a massive table. So okay, not massive, but like reasonably big, but you have no restriction on the sizes. I'm just going to create this table here called big employees. There's just got a little bit of recursion going on, and I'm basically creating 10 million entries. You'll see that this will run pretty quick, and we have a couple of seconds.
Yeah.
Yeah, it's very fast. So while that runs, it should start producing rows very shortly. So while we're waiting for this, it might be spinning up the warehouse because this account was offline for a bit. Any other questions that I can answer so long? Right. There we go. Yeah, it was taking a bit longer than it did yesterday when I was testing. I mean, this isn't even the fun or interesting part. I want to get to the zero copy cloning, where I'm taking 10 million rows and cloning them instantly. Curse of the live demo, eh? Yeah. I'll just cancel it. I think I still have it here. Okay, cool. Actually, I still have the table. I don't have to go and recreate it. So here we have table called big employees. We've got 10 million rows of data in here. And what I want to do now is I want to clone that table. You can see it took 460 milliseconds. And if you check the count star of the rows, 10 million rows of data in that clone table. So I think like that's like.
Use Burmese. Won't get you leads on LinkedIn to your marketing level. You come here.
You put on 10 million, I think God we can send it quick.
Yeah, so yeah, so if you want to do analysis on that data, so as long as you've solved the if you've solved the ingestion part of like getting those 10 million leads into Snowflake, so say they're coming from a HubSpot, you've already got a HubSpot integration, you can hook HubSpot in, and you've got a share. So in your database catalog, the HubSpot database will show up. It'll have a little icon next to it that'll show you that it's a share, and you can straight up start querying your HubSpot data without that data actually having to move or get piped through. It's just there, it's available. Then the next item that I think is really interesting is when that's done a bit of data analysis or engineering is, like it's not often the perfect world where we have nice, clean rows and columns that we need to deal with. Oftentimes when you're working with APIs, you're going to get semi-structured data. It's going to be like in a JSON format or maybe Parquet. And writing SQL and querying that kind of stuff is quite tricky, and that's oftentimes where data engineers either revert to Python libraries and load things into data frames and transform them and stuff. Snowflake has made a lot of those kind of things largely redundant by being able to just query semi-structured data with SQL. And how they've achieved that is with this file format called, not file format, data type called variant. It can basically hold any kind of data. So it can be semi-structured data. You can even put images in a variant column. Now there are some restrictions in terms of like the value, like the number of like the size of the data that you can store in a variant column, but it's plenty. Like so in each row of data in a variant column, you can store quite a bit of information. Yes, yeah. So it is variant. So I'm going to create this table called raw events, and you'll see that it has some standard columns. So an ID, a timestamp, and then this payload. And then I'm going to insert this rather messy looking little bit of JSON data in here. And oops. You'll see that should insert some rows. And now what you can actually do is you can literally like reference these elements inside of your JSON payload straight from like using SQL and like straightforward typecasting, and you'll turn that JSON payload that you guys can see that looked like that into nice clean rows and columns. And there you go. No Python libraries required, no wrangling of the data and like trying to figure stuff out. You're basically just querying this JSON straight as it is. Then in addition to that, they've got this really cool function called lateral flatten. And what you can do there is you can explode arrays of data within a JSON file. So say you've got like some kind of element that sits within your thing and that needs to be exploded into a whole bunch of different rows. Lateral flatten. So here you can see I'm basically taking the input of the payload element and then its specific items, and I want to explode them. So if I run this guy, you'll see that it now goes and expands them into like the SKU and quantity and the order total. So that's a really cool use case. And then also with these things, you can also do any kind of aggregation straight on semi-structured data. So you can see, we're doing a sum over the content of a JSON column where the payload action is purchased. And once again, it's all straightforward ANSI SQL, and then Snowflake have, of course, added a whole bunch of fantastic features that sit around it that help you interact with the data. And then lastly, you can even, deploy this little transformation if you want as a view where you can query and interact with the data. So say, for example, I want to do purchase details, and then we're querying this view. See that it now starts to look like a data set that one can work with. All right, then next one. I am cognizant that we are running a little bit short on time. So this is for Elastic Compute. I just wanted to demonstrate the stuff that I was speaking about earlier around how easy it is to set up computer. Like essentially what this short command is doing is it's creating a virtual warehouse that's got CPU, memory, and SSD. You know, so there's no complicated process. It's, you know, it's basically a one-liner. So I'm going to use my context as this demo database that I'm in, and I'm going to create this warehouse. You can see its size is set to extra small. If nothing happens for 60 seconds, the warehouse shuts down automatically. If I run a query against it, it'll spin up automatically. And when I'm creating it now, so say I'm busy provisioning 50 warehouses, make sure that they're all initially suspended. Otherwise, they're all going to run for a minute and then shut down again. You can see how quick it is. So there I've created a warehouse, and I can now spin up this warehouse. And then once again, if I want to see like, well, flip, how many warehouses do I have? I've got simple commands like show warehouses, like demo elastic. Ah, there we go. Just started that warehouse. Now, you know, while we're talking here, you know, queries can be busy running on this warehouse. And I see like, flip, we actually need to scale this warehouse up. Once again, it's simple. It's standard SQL, alter warehouse set. And I can spin this warehouse up to a medium within, you know, what's that, 51 milliseconds. And that warehouse now has like 4 times the amount of compute that's available. And I can verify that that is actually the case. I do show warehouses like, and you can see this guy's size is back to medium. And then similarly, I can set it back to extra small. And if I suspend this warehouse, then I'm not consuming any credits. It's not doing anything. It's there, it's available. And once again, with your role-based access control hierarchy, like that, going back to that slide that I showed earlier, you know, governance sitting across the board at the bottom, you can control who has access to this warehouse, who can use it, and then you've got like a ton of monitoring features around it as well. Quickly going through some of the other points is you can also get multi-cluster warehouses. So this is basically where you need concurrency. You don't necessarily want to scale up your compute, but you want lots of concurrent users. So think you've got like a large BI team, lots of people interacting with the warehouse, lots of people running different queries in parallel. You can set this warehouse up to actually scale out as well. So it'll spawn up separate instances of that warehouse in parallel. Once again, like the more clusters and stuff you have, the more credits you are going to be consuming. But it's really clever in that it'll actually go and detect like, hey, okay, we've got like this busy period, and it'll scale the warehouse out to a certain point. And then when it notices that the query load is reducing, it'll scale that warehouse back in. So you've got the seamless experience where it will expand and contract as your users require it. Then the next one that I quickly want to get through, I really want to get to the quiz, is you can also do sharing. So once again, what I'm doing here is I'm basically, I'm not sharing this data with any other account, but you can impersonate a share as well to see what your shared data will look like. So when you're busy doing development, you're just letting, okay, cool, I'm going to go share this data, happy days, and then after the fact, you realize that you've exposed a column that you shouldn't have, and then you don't know whether or not they have had access or so. Like, there's lots of features to make sure that those kinds of things don't happen. So what I'm going to do here is I'm going to create a product catalog, and I'm going to insert some values in there. And what I'm going to do now is I'm going to create a secure view. So the consumer won't be able to see the definition of this view. And I'm only going to filter it for products that are in stock. And then I'm going to go and create a share called demo share. Very creative. And I'm going to grant usage on the database to the share, and I'm going to grant usage on the schema to the share as well. So that the share, that is object called the share, now has reference to what schema, what database, and then what view the share can access. So this is like kind of a governance part. Of course, this is now very like a very basic example, but you can delegate this once again through your role-based access control hierarchy. So you've got like fine-grained control over what shares can see what with whom. So now what you can do is just quickly inspect that share just to confirm that everything's in order. So you can see here's the definition. These are the objects that it can share. So it can use this demo DB. It can use this schema called sharing demo, and then it can use that specific view within that schema. So what I can do now, and this is very useful for testing, is you can set something called the simulated data sharing consumer. And I can say, like, I've made up a fictional account there called datalab df79 something. And what this does is it actually changes my session that I'm currently connected in to impersonate as if this data, the share has now been configured with that account. So if I now go and query the shared products table, I can see that it will only return products that are in stock. And then just to show you that I'm not making this up, I'm going to unset that session. And if I'm going to query this view now, you'll see that there's slightly different things that come through. Sorry. So let's see if I now go and make an update. And I go and impersonate the share, and I go and check out shared products. Now we should see that product ID 1's price has now changed, and it's now $39.99. Then the last one that I want to get to, I'm going to be quick as I can, is these items around streams and tasks. So basically, this is like built-in change data capture on any kind of object. So on a table, on a stage inside of your account, you can. I'm going to create a table. I'm going to create two tables, so source and a target table, and then from there, I'm going to create a stream on my source table. So this will now start tracking changes that have come into that source table. So if I now call this insert command here, so data is now landed inside of this table, I can actually query that stream of data, and it'll tell me what like these metadata action updates, row ID. There's also ones for delete. So it's going to now track what actually happened on that table. You can see, like, once again, there's nothing complicated about setting it up. It's a one-liner, create or replace stream on table. And here we can see that it's pending. So that means that the stream hasn't been consumed yet. And you can see that the metadata action was insert. And then there's some other row ID information that Snowflake uses internally to track it. Once again, this stuff you can then use elsewhere in your processes. So what I can do now is I can now consume this stream. So I've got a merge query written here that's basically going, I'm selecting from the stream. So I'm not selecting from the table itself. I'm selecting from the stream, and I'm saying, well, only where the metadata action was insert. And if there's any matches, then do an update. If there's no matches, do an insert, and you can consume the stream. And if I check the stream now, you can see the 3 rows were inserted, no rows were updated. If I select the stream now, it should be empty. So that means that stream has been consumed. So, and if we check out the target table, then you can see that the 3 rows are now in there. But now let's say we do some updates. So I'm just going to run a couple of these quick. So we're going to do some status changes, and we're going to let's see, what else are we going to do? Yeah, status changes, and then also we're going to do a delete. So let's do those 3 now. And if we now look at the stream, like, so the content that sits in the stream, can see here that one has changed to shipped, and you can see that's an insert. There was a delete, an update, and you can see there's 2 entries now for some of these. And the reason how it does that is when it does these changes, it actually tracks 2 changes. So one is for the updating of the record, and the other one would then be for the insertion or the deletion of the existing record. So that's why there's 2 entries for those ones that we changed. What you can do then is, cool, now you're tracking changes on this table. So as stuff happens in your source table, it's tracking what's happened to those tables. So now you can set up something like a task to automate it. So here I've got a very simple task that will run once every minute, and it will basically check, does the stream have data? If there's data in that stream, go and perform a merge operation, and just basically run once a minute. So I'm going to quickly create that task now. Let's see. There we go. And I am going to, oops, demo warehouse. Sorry, that's wrong. CDC demo. They can just do all XML warehouse. Cool. Right. So I've got a task there, and I'm just going to let that task run, and then I can execute it. Cool. Scheduled to run immediately. Just give it a few seconds, and we should see that the stream is consumed. So it's probably still just spinning up. Let's give it a few seconds. Yeah, sure.
Is there a way to set it so that once records hit the stream, it automatically is ingested on the other side?
Yes, yeah. So so that will typically be done through, you can do it through tasks. You can also, of course, do it through, basically you have this, sorry, when stream has data, so for your specific stream. So typically, like how I would set it up is that, like, if you have your task DAG, so that you have, like, say, if there's data that needs to land in like a specific stage or table that then triggers this downstream process, then start that with a task. And this task will basically like fire every minute, but it won't actually do anything if there's not data in the stream. Let's see, I think they might not be. Hit execute the task. It might just be taking a while to run it. That'd take a minute or something sometimes to get set up. We can actually see here if it's run or if I just made a mistake. Okay, so it's still busy. It's scheduled. Cool. All right. I'm not going to bore you guys with me debugging something that I should have gotten, should have just taken a look at before. So apologies for that. But let's get on to the fun stuff. We have a quiz, and we've got some cool prizes there, thanks to Snowflake. All right, here we go.
Knowledge.
Okay, so cool. We'll give everyone a moment or two to sign in. And then I'll go over the rules. Yes. Sorry? Oh.
It's always.
Is it the wrong one? Oh, snap. Does it not work?
People struggling to get in.
Is it not working? Let me quickly see.
It was just fine. It's just a me error there.
Let's see. Yeah, I mean. Yeah, I mean.
Like an A.
I don't know. It's like 300 bucks or something.
All right. Everyone signed in, ready for the quiz? Just a couple of rules. So obviously it's going to test for accuracy. The questions are super difficult. It's a combination of speed and accuracy. Right. So first question. All right. Okay. So actually there's I was wondering where that is. Cool. Everyone's in there. So first question. Which of these are key features of Snowflake? Pick 3. All right. And the answers are zero copy cloning, data sharing, and elastic compute. Project management, you probably could, but I wouldn't. Then on to the next one. So this is the next question. Which of these are core principles of the Snowflake design philosophy? Pick 3. Yes. Right, there we go. Fantastic. It's easy, trusted, and connected. Excellent. All right. Here we go on the leaderboard. We've got Yashiv coming in quick, 10 seconds. And then it's neck and neck for second place. 13 seconds for everyone. All right, cool. Next up. Which of these are core Snowflake workloads? Choose all that apply. A little bit of a trick question because the correct answer is all of the above. All right. And on to the last question. Where can Snowflake be deployed? Choose all that apply. And yes, so Snowflake can be deployed on AWS, on GCP, and on Azure. On-premise is not an option. Yes, unless you can build a data center. And that is a wrap. So, oh no, wait, that's not a wrap. Sorry, we've got one more. Sorry about that. I for some reason thought like the leaderboard was going to show it. All right, everyone. So last question. Let's see how it goes. If I deleted a table, how would I restore it? Pick one.
I hope so.
Okay, people were saying it's undrop table. Correct. Oh, no one wanted to call the DBA. Poor guy. All right, there we go. Congratulations to Yashiv, Chaz, and Austin. All right. And that is a wrap from me. Thank you so much for your time, everyone. I really appreciate it.